Welcome to Still Science Lab. Tonight, we are going to confront a chilling sequence of words that has quietly sent shockwaves through the highest echelons of modern astrophysics. We are going to explore a profound, unsettling paradigm shift brought to us by the most complex machine ever placed in the void. A shift encapsulated perfectly in our title. This is not our universe. This is the terrifying reality the James Webb Space Telescope just found. We have spent the last century painstakingly building a mathematical and physical fortress to explain our existence. We wrote the laws of cosmology, we mapped the birth of stars, and we confidently charted the expansion of the dark. But when we finally built an eye powerful enough to look all the way back to the absolute edge of the beginning, the reflection staring back at us in the dark did not obey our laws. Settle into the quiet. Let go of the comforting certainties of the world you thought you knew, and let us dive into the terrifying anomaly that is currently breaking our understanding of reality. A Nobel Prize winner looked at the raw, unyielding data returning from the James Webb Space Telescope and said four very specific, very heavy words. Four words that absolutely no one in the global cosmological community has been able to definitively, publicly refute since the moment he uttered them. This is not our universe. In the realm of theoretical physics and deep space astronomy, scientists do not typically speak in hyperbole. They are cautious, meticulous, and heavily bound by the strict constraints of peer review and statistical significance. So, when a statement like this is made, it is incredibly important to understand that it was not meant as a piece of poetic flair. It was not a philosophical provocation designed to sell books or generate headlines. It was a cold, direct, and literal statement about the data itself. It was a brutal assessment of what the telescope actually found when it opened its massive, gold-plated mirrors and looked deeper into the freezing, primordial space than anything built by human hands has ever looked before. Since those four words were spoken, the usually vibrant, debate-filled halls of cosmology have gone unusually, deafeningly quiet. This silence is not the silence of awe, nor is it the quiet contemplation of a mystery waiting to be solved. It is the heavy, suffocating silence of a profound existential crisis. Cosmologists are quiet not because they think the statement is fundamentally wrong, but because they absolutely do not know how to explain why it might be right, and they are terrified of what it will mathematically cost us if it is. We are currently standing at the very edge of a crumbling paradigm. We are looking at a reality where the foundational physics breaks, where the beautiful, elegant mathematics that govern the cosmos simply do not close, and where the deep, fundamental questions that were supposed to be permanently settled decades ago have suddenly, violently reopened. The telescope is still running out there in the freezing dark of the second Lagrange point. The data is still relentlessly arriving on our servers, and the picture it is patiently building piece by piece does not look anything like the universe we confidently thought we lived in. To truly understand the crushing weight and the terrifying gravity of those four words, you must first deeply understand the man who spoke them. The person looking at the James Webb telemetry and sounding the alarm is not a fringe theorist or an internet sensationalist. His name is John Mather. For those uninitiated in the complex history of modern astrophysics, John Mather is an absolute titan. He spent 20 years of his life meticulously designing, building, and eventually analyzing the data from the Cosmic Background Explorer, or COBE, satellite. His singular, consuming mission was to measure the cosmic microwave background, the faint, thermal glow left over from exactly 380,000 years after the violent beginning of everything. This is the oldest light in the cosmos, the lingering heat of the Big Bang itself. When Mather's instrument finally measured those ancient photons, it mapped the temperature variations of the infant universe to a staggering precision of 1 part in 100,000. And what he found in that ancient, fossilized light was an absolute triumph for modern physics. He found those temperature variations exactly, perfectly where the standard model of cosmology predicted they would be. He essentially proved the math right. He gave humanity the ultimate empirical reassurance that our grand theories about the birth and expansion of the cosmos were not just clever human inventions, but fundamental truths of nature. The Nobel Committee in Stockholm awarded him the highest honor in science in 2006. They did not give him the Nobel Prize for proposing a wild, new theoretical concept. They gave it to him for confirming our existing framework with a precision so incredibly sharp that it left absolutely no statistical room for doubt. He was the man who drove the final, golden spike into the foundation of the standard cosmological model. He cemented the architecture of reality as we know it, giving generations of subsequent scientists the confidence to build upon his unshakable bedrock. This is the exact reason why his current warning is so profoundly terrifying. The very man who practically wrote the definitive textbook on the structure of the universe, the man whose entire legacy is built upon confirming the standard model, is now the one looking at the brand new, high-definition data from the James Webb Space Telescope and telling us that the structure is wrong. The architecture does not match. The physics do not align. The man who proved the universe made sense is now standing before us, pointing at the deep field images of the cosmic dawn and stating that the universe we are observing is fundamentally incompatible with the universe we mathematically mapped. When you build a $10 billion machine to look back toward the absolute beginning of time, you do it with a very specific set of expectations. We designed James Webb to peer through the thick, obscuring dust of the cosmos and capture the stretched, infrared light of the very first galaxies slowly, agonizingly pulling themselves together from the primordial hydrogen gas. According to the standard model, the very model John Mather helped prove the early universe should be a chaotic, messy, and relatively dark place. It takes hundreds of millions of years of slow, gravitational accretion for matter to cool down, clump together, and form anything remotely resembling the massive, structured galaxies we see in our modern, local neighborhood. We fully expected Webb to find tiny, fragile, disorganized clusters of early stars, the dim, flickering embers of a universe just barely waking up from the cosmic dark ages. We expected to look back and see our own humble, slow beginnings, confirming the timeline we had so carefully written. Instead, when the golden mirrors aligned, and the deep space photons finally hit the highly sensitive detectors, the images that materialized on the screens on Earth were an absolute impossibility. The structures lurking in the deep past were not fragile, they were not dim, they were not disorganized, they were monolithic, sprawling, and impossibly massive. The sheer scale and maturity of what Webb found instantly triggered a massive, systemic failure in our cosmological operating system. When Mather says, "This is not our universe," he means it in the most literal, mathematical sense conceivable. The mass distribution, the timeline of star formation, and the gravitational geometry required to create the structures. Webb is currently photographing fundamentally violate the established physical laws of the universe we thought we inhabited. We are forced to confront a deeply unsettling existential realization. For all of our technological prowess, for all of our brilliant mathematics, and for all of our Nobel Prizes, we might be nothing more than arrogant children standing on the shores of an ocean we do not actually understand. We built the perfect eye to gaze into the abyss, confident that the abyss would validate our intelligence. But the abyss has its own rules. The dark holds secrets that our equations simply cannot contain. The realization creeping through the scientific community is that we have not merely discovered an anomaly, we have discovered a fatal crack in the foundation of our reality. The universe we mathematically constructed, the one we teach in our universities and celebrate in our textbooks, might simply be a local illusion, a flawed model built by a species that was looking at the cosmos with a blindfold on. And now that James Webb has finally ripped that blindfold off, the blinding, impossible truth of the cosmos is pouring in, rewriting the past and threatening the entire framework of our future. We are adrift in a cosmos that refuses to obey the laws we wrote for it. The illusion of our cosmological supremacy began to officially, publicly fracture in the cold, early months of the year 2023. The scientific method is built upon a foundation of quiet, methodical observation. But occasionally, a piece of data arrives that acts like a violent seismic event, silently destroying the architecture of a discipline from the inside out. In February of that year, a peer-reviewed paper was quietly published, detailing the findings from a deep field observation conducted by the James Webb Space Telescope. The paper did not contain theoretical speculation or abstract mathematical philosophy. It simply contained the spectral analysis and photometric measurements of 6 specific, extremely distant points of red light hanging in the absolute dark. These 6 smudges of ancient photons were photographed at a distance that places them exactly 500 to 700 million years after the absolute beginning of everything, an era cosmologists romantically refer to as the cosmic dawn. When the astrophysicists processed the data and calculated the true physical nature of those 6 distant lights, the numbers that materialized on their screens were so profoundly, aggressively wrong that they initially assumed the telescope's highly calibrated sensors had suffered a catastrophic hardware malfunction. To understand why these 6 specific galaxies triggered a localized panic among the smartest people on Earth, we must forcefully abandon our terrestrial intuition of time and look at the strict, unyielding timeline dictated by the standard model of cosmology. In the established narrative of our universe, the aftermath of the Big Bang was a sprawling, expanding ocean of hot, chaotic, unstructured particles. As the universe expanded, it cooled, eventually plunging into an era known as the Cosmic Dark Ages, a period lasting hundreds of millions of years where absolutely nothing produced light. Slowly, agonizingly, the inexorable pull of gravity began to collect the drifting clouds of primordial hydrogen and helium into slightly denser pockets. According to our best, most rigorously tested supercomputer simulations, this process of gravitational accretion is inherently incredibly slow. It takes hundreds of millions of years for gravity to pull enough gas together to ignite the very first, fragile, short-lived stars. It takes hundreds of millions of years more for those stars to loosely group together into small, disorganized, wispy dwarf galaxies. The Standard Model explicitly demands that the universe at 500 million years old should look like a vast, dark wilderness dotted with only the faintest, smallest, most primitive campfires. But the James Webb Space Telescope did not find primitive campfires. When it peered into that incredibly specific, ancient epoch, it found sprawling, towering, monolithic metropolises of burning nuclear fire. The measurements revealed that each of these 6 individual galaxies contained a stellar mass equivalent to tens of billions of our own suns. To put that staggering figure into a crushing, physical perspective, our own home galaxy, the Milky Way, contains roughly 100 to 400 billion stars, but it required nearly 14 billion years of slow, continuous, undisturbed cosmic evolution, cannibalizing hundreds of smaller dwarf galaxies over eons to achieve that massive size. The 6 objects James Webb photographed had managed to achieve a significant fraction of the Milky Way's total mass in a mere fraction of a cosmic blink. They were impossibly huge, hopelessly mature, and violently fully formed in an era where they had absolutely no physical right to exist. The sheer, terrifying mass of these objects created an immediate, insurmountable mathematical paradox. When you calculate the total amount of available baryonic matter, the normal, physical stuff that makes up stars, planets, and people that was theoretically present in that specific, early volume of the universe, the numbers simply do not add up. These 6 galaxies alone contain more stellar mass than the entire observable universe was mathematically supposed to have even managed to convert into stars by that specific point in time. It is exactly like walking into a massive construction site on the very first morning of building, only to find a fully completed, towering 100-story skyscraper sitting in the center of the dirt lot, with the wet concrete still drying. The building materials to construct it were not even supposed to have been delivered yet, and the time required to assemble it had not yet passed. But the massive, undeniable structure is standing right there, casting a heavy, terrifying shadow over everything you thought you knew about physics. Because of this brutal, irreconcilable contradiction, the astrophysicists who published the paper bestowed a haunting, highly unusual moniker upon these 6 anomalies. They dubbed them the universe breakers. In the sterile, cautious lexicon of academic astronomy, scientists do not use words like breaker lightly. They did not choose this name to be sensational. They chose it because it is the most accurate, literal description of what these massive objects actively do to our foundational equations. They break the universe. Specifically, they break the absolute, fundamental physical laws that govern how matter collapses under the influence of gravity to form stars. The process of star formation is not a peaceful, highly efficient assembly line. It is a chaotic, violent, and inherently self-limiting war between opposing physical forces. When a massive cloud of primordial hydrogen gas begins to collapse under its own gravitational weight, it gets incredibly dense and hot in the center until nuclear fusion finally ignites, birthing a new star. But the absolute second that star ignites, it becomes a violent, raging engine of destruction. It unleashes a massive, blinding torrent of intense ultraviolet radiation and powerful stellar winds that aggressively push outward against the surrounding, uncollapsed gas. This intense outward radiation pressure violently physically blows the remaining cloud of hydrogen away, permanently starving the region of the very fuel it needs to build more stars. Because of this brutal physical feedback loop, the process of star formation in the universe is incredibly, fundamentally inefficient. In a typical galaxy, only a very tiny fraction, usually around 1 to 5% of the available gas, actually manages to successfully collapse into stars before the rest of the material is violently blasted away into the empty void. This is not a theory. This is the basic, unbreakable law of thermodynamics and gravity operating in a vacuum. But the universe-breaker galaxies completely, impossibly violate this fundamental law. To account for the sheer, staggering volume of stellar mass present in those 6 objects at a time so dangerously close to the Big Bang, the Standard Model dictates that they would have needed to convert nearly 100% of their available gas into stars. They would require a star formation efficiency that borders on absolute physical impossibility. It means that somehow, in the deep, primordial dark of the cosmic dawn, gravity managed to pull tens of billions of solar masses of gas together so incredibly fast and compress it so perfectly that it bypassed the laws of thermodynamics entirely. It means the violent radiation of the first igniting stars somehow did not blow the remaining gas away, allowing the galaxies to gorge themselves on matter at a rate that defies everything we know about the mechanical physics of the cosmos. We are forced to sit in the dark and contemplate the terrifying implications of an impossible process. If the universe-breaker galaxies are real, and the highly calibrated, rigorously tested data from James Webb insists that they are, then our entire understanding of how matter behaves on a cosmic scale is fundamentally flawed. We built our cosmological models based on the strict assumption that gravity and radiation acted the same way in the deep past as they do today. But these 6 sprawling, ancient monoliths suggest a reality where the rules were different, or worse, a reality where our rules have simply never been right in the first place. They sit there in the deep field of the telescope's vision, glowing with the ancient, angry light of tens of billions of suns, silently mocking the beautiful, elegant equations we wrote to constrain them. The discovery of the universe breakers represents a profound psychological trauma for modern cosmology. We thought we were reading a meticulously structured historical record of the cosmos, a book where the beginning was slow, simple, and easy to understand. But James Webb has flipped back to the very first chapter and found a highly complex, chaotic, and heavily populated civilization thriving in the dark margins where there should have been nothing but empty space and drifting atoms. We are looking at ghosts of impossible leviathans, ancient structures that are too big, too bright, and too beautifully complex to exist within the mechanical framework of our reality. They are the ultimate cosmic paradox, massive, undeniable objects that simply cannot be there, yet they absolutely are. And as we stare at their stretched, red light slowly decoding on our monitors, the terrifying realization begins to fully set in. If our foundational understanding of how gravity and matter interact is broken at the very beginning of time, then everything we have built upon that foundation, our understanding of dark matter, the expansion of the universe, and our own ultimate fate in the dark is suddenly, violently suspended over an abyss of absolute, terrifying uncertainty. We are not just looking at 6 unusually large galaxies. We are looking at the frayed, tearing edges of our own reality, unraveling right before our eyes in the freezing, silent depths of the primordial dark. When the staggering implications of the universe-breaker galaxies first began to ripple through the global astronomical community, the immediate, overwhelming reaction was not one of triumphant celebration or quiet awe. It was a reaction of profound, desperate skepticism. The entire foundation of the scientific method is built upon the rigorous, unrelenting attempt to break new hypotheses, to violently tear down anomalous data until only the absolute, undeniable truth remains standing. In the strict, unforgiving hierarchy of modern physics, it is infinitely more probable that a human being made a mathematical error or a machine experienced a microscopic calibration glitch than it is for the fundamental laws of the cosmos to simply be wrong. When physicists are confronted with data that mathematically threatens to collapse the standard cosmological model, their immediate, deeply ingrained immune response is to launch a massive, coordinated search for a mistake. They wanted the data to be flawed. They desperately needed the James Webb Space Telescope to be lying to them, because the alternative that the universe behaves in ways we fundamentally do not understand was far too terrifying to casually accept. And so began one of the most exhaustive, relentless, and frantic periods of data verification in the history of astronomy. A desperate hunt for an error that ultimately culminated in the most chilling realization of all. The first line of defense against the impossible was to ruthlessly stress test the theoretical models themselves. The astrophysicists retreated to their supercomputers, determined to push the existing laws of physics to their absolute, breaking limits to see if they could somehow forcefully squeeze these massive galaxies into the accepted timeline. They took the mathematical dials that govern the universe in our simulations and cranked them all the way past the red line. As we know, star formation is an inherently inefficient process, typically converting only a tiny fraction of available gas into actual burning stars before the violent radiation blows the remaining material away into the void. To try and explain the sheer mass of the early anomalies, researchers completely removed this physical limitation in their models. They programmed the simulations to run at an absurd, physically impossible star formation efficiency of 100%. They essentially commanded the simulated universe to flawlessly, instantly convert every single atom of available primordial hydrogen into stellar mass without a single ounce of wasted energy or blown-out gas. It was a theoretical scenario so frictionless and perfect that it defied the basic laws of thermodynamics. Yet, even when granted this impossible, magical level of efficiency, the standard model still catastrophically failed. The simulated universe simply could not physically gather the necessary raw materials fast enough to build those sprawling monolithic galaxies within a 500 million year window. The mass of the objects stubbornly refused to fit inside the mathematical box, even when the box was stretched to the absolute breaking point of physical reality. When manipulating the visible baryonic matter proved entirely insufficient, the physicists turned their desperate attention to the dark sector. They looked at dark matter, the invisible, ghostly scaffolding that provides the necessary gravitational gravity wells to pull ordinary gas together. They hypothesized that perhaps the early universe contained highly anomalous, extreme concentrations of dark matter, massive invisible halos that acted like hyper-efficient gravitational vacuums, violently sucking in gas at unprecedented rates. They fed these extreme, highly concentrated dark matter parameters into the supercomputers, hoping that this invisible force could mathematically bridge the impossible gap. But once again, the mathematics coldly refused to cooperate. Even with the most extreme, statistically improbable dark matter halos anchoring the simulated galaxies, there simply was not enough time in the young universe for the baryonic matter to fall into those gravity wells, cool down, and ignite into tens of billions of stars. The physicists had thrown every theoretical lifeline they possessed at the problem, pushing the assumptions of early cosmic physics into the realm of the absurd, and it was still mathematically insufficient. The models were not just slightly off, they were failing by orders of magnitude. Having exhausted every possible theoretical loophole, the scientific community turned its intense, highly critical gaze toward the machine itself and toward the specific methods used to interpret its faint, red data. Historically, astronomy is littered with the ghosts of spectacular, universe-altering discoveries that quietly vanished upon closer inspection. We all remember the infamous faster-than-light neutrinos that threatened to break Einstein's theory of relativity, which ultimately turned out to be nothing more than a loosely connected fiber optic cable in a laboratory in Italy. We remember the initial, blurry images from the Hubble Space Telescope caused by a microscopic flaw in the curvature of its primary mirror. It is a deeply comforting historical precedent. When the universe seems to break, it is almost always just a smudge on our lens. The researchers desperately hoped that the James Webb Space Telescope was suffering from a similar, highly complex software glitch or a subtle calibration error in its incredibly sensitive infrared detectors. To definitively prove or disprove the data, they had to rigorously verify the measurements using two completely different, independent methods of astronomical observation. The initial, terrifying mass and distance estimates of the universe-breaker galaxies were made using a technique called photometry. Photometric observation involves taking high-resolution images of the galaxies through a series of specific, colored filters. By measuring how much light passes through each filter, astronomers can make a highly educated, mathematical estimation of the galaxy's redshift, how far its light has been stretched by the expansion of the universe, which in turn dictates its distance and age. However, photometry is widely acknowledged to be a relatively blunt instrument. It is entirely possible for a nearby, highly dusty galaxy to masquerade as an incredibly distant, ancient one, because the thick cosmic dust reddens the starlight in a way that perfectly mimics extreme cosmological redshift. The scientists clung to this possibility like a life raft. They assumed that the universe breakers were actually just ordinary, unremarkable galaxies sitting much closer to Earth, heavily obscured by thick, deceptive clouds of interstellar soot. To completely rule out this comforting illusion, the astronomers deployed the heavy artillery of astrophysics, spectroscopy. While photometry is like guessing a person's age by quickly looking at a photograph of them through a tinted window, spectroscopy is like sequencing their DNA. The James Webb Space Telescope used its near-infrared spectrograph to capture the faint light from these specific galaxies and meticulously split it apart into a highly detailed, high-resolution barcode. This spectral barcode reveals the absolute, undeniable chemical fingerprints of the atoms burning inside the galaxy, and exactly how far those specific fingerprints have been shifted into the infrared spectrum by the expansion of space. Spectroscopy does not estimate. It provides cold, empirical, physical certainty. It is the most rigorous, unforgiving tool in the entire arsenal of modern astronomy. When the spectroscopic data finally arrived and was processed by the independent teams of researchers, the last remaining hope for a simple, comforting mistake was violently, permanently extinguished. The spectral barcodes perfectly matched the initial photometric estimates. The heavy, thick dust illusion was unequivocally ruled out. The galaxies were not masquerading as ancient monoliths. They truly were sitting at the absolute edge of the observable universe, existing a mere 500 million years after the Big Bang. The light signature was uncorrupted. The mass estimates were terrifyingly accurate. The telescope was not miscalibrated. The sensors were not hallucinating. And the software was functioning with a pristine, mathematical perfection that bordered on the miraculous. This is the point where the narrative of modern cosmology takes a deeply unsettling, horrifying turn into the existential dark. The failed search for a mistake is the most terrifying outcome conceivable. If the telescope had been broken, if the calibration had been flawed, or if the researchers had simply misplaced a decimal point in their photometric analysis, the scientific community could have breathed a massive, collective sigh of relief. We could have written a patch for the software, recalibrated the mirrors, and gone back to our comfortable, fully understood universe. But the scientific process worked exactly as it was designed to work. It was subjected to the most intense, hostile, and desperate scrutiny imaginable, and it held together flawlessly. Every single independent check, every balance, every rigorous stress test, and every secondary verification returned the exact same impossible, universe-breaking result. We are left standing completely exposed in the freezing void, stripped of all our comfortable excuses. We can no longer blame the machinery, and we can no longer blame the methodology. The James Webb Space Telescope is operating with a level of precision that is almost frightening, and it is executing its mission perfectly. It is acting as a flawless, unblinking mirror held up to the edge of time. And the profound, inescapable horror is that the reflection staring back at us is fundamentally broken. The failure to find an error in the data means that the error resides entirely within our own minds. It means that the standard model of cosmology, the beautiful, elegant mathematical operating system that we have used to make sense of the void for nearly a century, is fundamentally incapable of describing the reality of the early universe. The pristine, verified data sits on our servers, silently mocking our ignorance, proving with cold, empirical certainty that the cosmos is capable of assembling sprawling, massive structures in the dark far faster and far more efficiently than our laws of physics physically allow. The search for a mistake failed, and in that devastating failure, humanity is forced to realize that the universe is far more alien, far more chaotic, and far less understood than we ever dared to imagine, while the impossible, terrifying maturity of the ancient, primordial galaxies violently tore at our fundamental understanding of how matter behaved in the deep past. An entirely separate, equally devastating crisis has been quietly ripping apart our understanding of the universe in the present. This is not a debate about the distant, foggy edges of the cosmic dawn. This is a catastrophic failure occurring right here, right now, in the local geometry of our modern cosmos. Cosmology faces a central, practical challenge that supersedes almost all other theoretical inquiries: the precise measurement of the expansion rate of space itself. We are not merely attempting to figure out what the universe is physically made of. We are desperately trying to calculate exactly how fast it is currently tearing itself apart. This measurement is the ultimate, fundamental heartbeat of reality. It dictates the age of the cosmos, the ultimate fate of all matter, and the hidden, invisible mechanics that govern the empty void. For decades, the greatest minds in astrophysics believed they were slowly, meticulously zeroing in on a single, universally agreed upon number. But as our instruments grew sharper and our observations became flawlessly precise, the single number brutally split into two. We are now staring into a widening gap known as the Hubble tension, and it is perhaps the most profound, unsolvable nightmare in modern physics. To understand the sheer gravity of this nightmare, you must first understand what it actually means to measure the expansion of the universe. When we say the universe is expanding, we do not mean that galaxies are simply flying away from each other through pre-existing, static space, like shrapnel from a bomb moving through the air. The reality is far more conceptually terrifying. The galaxies themselves are largely stationary in their local neighborhoods, held together by their own internal gravity. It is the empty, silent void between the galaxies that is physically stretching. Space itself is spontaneously, relentlessly generating more empty space, carrying the galaxies further apart like islands adrift on a swelling, invisible ocean. To measure this expansion, cosmologists use a metric called the Hubble constant. It is calculated in kilometers per second per megaparsec. A megaparsec is an unfathomably vast distance, equivalent to roughly 3.26 million light-years. The Hubble constant simply tells us exactly how much faster a galaxy appears to be moving away from us for every single megaparsec of empty space that lies between us and it. It is the speed limit of the stretching void. To find this critical foundational number, the scientific community historically divided into two entirely separate, highly specialized camps, utilizing two completely different methods to measure the cosmos. The first camp looked backward, deep into the fossilized past. They utilized the magnificent Planck satellite to meticulously map the cosmic microwave background, the faint, static afterglow of the Big Bang itself. By studying the microscopic temperature fluctuations in this ancient, pristine light, they captured a perfect, flawless baby picture of the universe when it was a mere 380,000 years old. They took this flawless initial data, plugged it into our standard model of cosmology, our beautiful, elegant mathematical operating system of reality, and ran the simulation forward 14 billion years to see how fast the universe should theoretically be expanding today. It was a rigorous, mathematically pristine prediction based entirely on how the early universe behaved. The number the Planck satellite generated was incredibly precise, 67.4 kilometers per second per megaparsec. It was an elegant, reassuring number that fit perfectly within the established theoretical boundaries of our physical laws. The second camp did not look backward at the echo of the Big Bang. They looked outward at the messy, empirical, highly physical reality of the present. They built something called the cosmic distance ladder. This is a painstaking, step-by-step method of physically measuring the expansion of space in our local, modern, cosmic neighborhood. To do this, they rely on specific, highly predictable stellar objects acting as standard candles. They look at Cepheid variables, massive stars that physically pulsate, growing brighter and dimmer with a rhythmic, clockwork precision that directly correlates to their true, inherent brightness. Further out in the dark, they look at Type 1 as supernovae, the violent, cataclysmic explosions of white dwarf stars that detonate with a perfectly uniform, predictable luminosity. By carefully observing these pulsating stars and detonating stellar corpses in distant galaxies, and measuring exactly how much their light has been stretched into the red spectrum by the expansion of space, astronomers can calculate the expansion rate entirely independently of any theoretical models. They are not predicting how fast the universe should be expanding based on its birth. They are physically, empirically measuring how fast it is actually expanding right now. And the number they got was 73.9 kilometers per second per megaparsec. This is the precipice of the existential crisis. We have 67.4 from the early universe and 73.9 from the late universe. It is a gap of roughly 9%. In the messy, chaotic realm of everyday human life, a 9% discrepancy might seem like a perfectly acceptable margin of error, a minor rounding difference to be quickly dismissed. But in the realm of precision cosmology, where multi-billion-dollar instruments are calibrated to the width of an atom and standard deviations are meticulously calculated to the fifth decimal place, a 9% gap is not a rounding error. It is a catastrophic, irreconcilable, fatal chasm. It is a 5 sigma discrepancy, which, in the sterile, unforgiving language of statistics, means the mathematical probability of this gap being a random fluke or a temporary stroke of bad luck with the instruments is roughly 1 in a million. The terror of the Hubble tension is not just that the two numbers are different. It is the paralyzing realization that both measurements are internally, flawlessly consistent and have been independently verified time and time again. The scientists working on the Planck satellite data scrutinized their own work for years, searching for any possible thermal distortion or software glitch, and found absolutely nothing. Their calculation of 67.4 is mathematically perfect based on the early universe. The scientists building the distance ladder, utilizing the Hubble Space Telescope and an army of ground-based observatories, ruthlessly cross-examined their standard candles, constantly refining their measurements of Cepheid variables and supernovae to rule out any optical illusions caused by cosmic dust. Their calculation of 73.9 is empirically perfect based on the modern universe. Both teams are entirely, undeniably correct within their own parameters. Yet by the fundamental, unyielding laws of logic, a 9% gap dictates that they cannot simultaneously be right. This leads to a deeply suffocating, terrifying conclusion. If the measurement of the beginning is flawless, and the measurement of the present is flawless, then the invisible, mathematical bridge connecting the two must be broken. Our standard model of cosmology, the very framework we use to understand how the universe evolved from a hot, dense plasma into the sprawling, dark void we inhabit today, is missing a massive, fundamental piece of reality. The universe is physically expanding significantly faster today than the laws of physics strictly say it should be based on its infancy. It is as if you watched a car accelerate perfectly according to the laws of mechanics, and then, without any additional fuel or explanation, it suddenly surged forward, breaking the physical constraints of its own engine. The Hubble tension is a bleeding, open wound in modern astrophysics that refuses to heal. For years, the scientific community desperately hoped that the discrepancy was simply an artifact of our slightly imperfect older telescopes. They prayed that when the James Webb Space Telescope finally turned its golden, high-definition mirrors toward the standard candles of the distance ladder, the sharper, cleaner data would magically resolve the tension, bringing the 73.9 down to comfortably align with the 67.4. But the absolute opposite happened. When James Webb was aimed at the Cepheid variables, it did not find a mistake. It only made the existing measurements cleaner, sharper, and infinitely more undeniable. The gap did not close. It solidified. It became a permanent, structural feature of our observations. A discrepancy that survives every single systematic check, every rigorous stress test, and every deployment of a newer, vastly superior instrument is no longer a simple measurement problem. It has officially mutated into a terrifying physics problem. We are forced to look up into the deep night sky and accept that there is a phantom force, a completely unknown, invisible mechanism operating in the dark void that is aggressively stretching the fabric of reality faster than we can mathematically account for. The 9% gap is not just a disagreement between two teams of scientists. It is the exact, quantifiable measurement of our own profound ignorance. It is the widening space between the universe we comfortably thought we understood and the terrifying, alien reality we actually live in. And, as the void continues to stretch, accelerating into the black, we are left completely unmoored, standing on a shattered foundation, staring into a gap that threatens to swallow the entire history of modern physics. For a decade, the greatest astrophysical minds on this planet found themselves trapped in a grueling, invisible war against the very fabric of reality. When the 9% gap between the early universe and the modern universe first materialized, it was not immediately met with existential dread. The scientific establishment is inherently conservative and deeply pragmatic. They naturally assumed the discrepancy was a symptom of our own clumsy terrestrial limitations. They believed it was a smudge on a lens, an oversimplified assumption in a computer algorithm, or a subtle, uncorrected interference from the thick dust of our own Milky Way. And so began a relentless 10-year period of scientific purgatory. Teams of astronomers, physicists, and mathematicians dedicated their entire careers and billions of dollars in observational time to a single, desperate objective. They had to close the gap. They had to force the universe back into the neat, elegant, mathematical box that we had built for it. The effort was monumental, characterized by a level of obsessive, agonizing scrutiny that is almost entirely incomprehensible to the outside world. The observers, the men and women who spend their lives staring into the dark through the lenses of our most powerful terrestrial and orbital telescopes, decided to completely tear down the cosmic distance ladder and rebuild it from absolute scratch. They approached their own previous work with a brutal, unforgiving hostility. They went back to the Cepheid variables, those massive, pulsating stars that serve as our primary cosmic yardsticks. They meticulously re-evaluated the pulsating rhythms, searching for any microscopic sign that the stars were deceiving us. They hunted for hidden, binary companions that might be distorting the light. They rigorously analyzed the chemical composition of the stars, wondering if a slight variation in stellar heavy metals could be skewing their perceived brightness. They tore apart their data on Type 1a supernovae, desperately trying to prove that perhaps these cataclysmic explosions were not as perfectly uniform as we had arrogantly assumed. For 10 long years, they stripped the machinery of modern cosmology down to its individual nuts and bolts, meticulously polishing every single piece of data, praying to find the fatal flaw that would finally explain away the agonizing tension. But the flaw simply did not exist. Every time they rebuilt the distance ladder with tighter constraints and more rigorous parameters, the measurement of the modern expansion rate stubbornly refused to budge. It remained anchored at that terrifyingly high speed, completely indifferent to our desperate need for mathematical harmony. As the observers repeatedly failed to find a mechanical mistake in their instruments, the theoretical physicists frantically stepped into the void, attempting to save the Standard Model by rewriting the history of the universe itself. If the modern measurements were flawless, and the measurements of the cosmic microwave background were flawless, then the invisible bridge connecting them had to be modified. They hypothesized a bizarre, phantom force that they nervously called early dark energy. The Standard Model already relies heavily on dark energy to explain why the universe is expanding today. But this new, desperate theory proposed that a second, entirely different burst of dark energy briefly, violently ignited in the very first fraction of a cosmic second after the Big Bang. This theoretical phantom force would have aggressively pushed the universe outward for a fleeting moment before mysteriously vanishing entirely, altering the baseline geometry of the cosmos just enough to theoretically make the early measurements align with the modern ones. It was a mathematical band-aid, a highly contrived, invisible ghost forcefully injected into our equations to stop the entire framework of physics from bleeding out. But even this desperate, invisible ghost failed to save us. When theorists ran the complex simulations, they found that introducing early dark energy created massive, catastrophic ripple effects elsewhere in the model. It fixed the expansion rate, but it completely destroyed our understanding of how galaxies cluster together, contradicting other independent, highly verified observations. The universe stubbornly refused to accept our theoretical patches. It was actively rejecting every single attempt we made to reconcile its terrifying behavior. By the early 2020s, the global cosmological community was holding its collective breath, placing the entirety of its hope on a single, golden machine hanging in the freezing void a million miles away from Earth. The James Webb Space Telescope was supposed to be the ultimate, infallible arbiter. It was designed with an infrared resolution so impossibly sharp that it could pierce through the obscuring cosmic dust and look at the pulsating Cepheid variables with a clarity that the aging Hubble Space Telescope could never achieve. The scientists quietly told themselves that Hubble's older, slightly blurry vision had simply caused the starlight to bleed together in dense galaxies, artificially inflating the brightness measurements and creating a phantom gap. They believed, with a desperate, almost religious fervor, that when James Webb finally opened its massive, unblinking eye and looked at the distance ladder, the blurry edges of the data would finally sharpen, the error bars would shrink, and the agonizing tension would finally, quietly evaporate into the dark. In the year 2023, that long-awaited data finally arrived. James Webb turned its pristine golden mirrors toward the standard candles of the cosmos, meticulously capturing the infrared light of the Cepheids and the supernovae. The scientists back on Earth frantically downloaded the telemetry, ran the raw numbers through their supercomputers, and watched the results materialize on their screens. What they saw was not a resolution. It was the absolute, final cementing of a nightmare. The telescope did exactly what it was designed to do. It provided images of unprecedented, breathtaking clarity. It entirely eliminated the visual crowding. It pierced the cosmic dust flawlessly, and it produced the cleanest, sharpest, most pristine cosmological data in the history of human existence. But the gap did not close. The terrifying discrepancy did not vanish into the static. In fact, by completely stripping away the noise and the uncertainty of the older measurements, James Webb only made the gap cleaner, sharper, and infinitely more undeniable. It essentially took a blurry, terrifying shadow lurking in the corner of the room and turned on a massive, high-definition spotlight, revealing a monster that was fully real, fully awake, and staring directly back at us. When the absolute best, most expensive, and most flawlessly engineered machine ever created by our species looks directly at a problem and confirms that the problem is real, all of our comfortable excuses instantly evaporate. We have spent an entire decade desperately trying to blame the tools. We blamed the software, we blamed the dust, we blamed the atmosphere, and we blamed our own terrestrial incompetence. But the data from 2023 violently strips away the comforting illusion of human error, a discrepancy that survives every single systematic check, outlives a decade of relentless theoretical assaults, and grows infinitely sharper and more pronounced with the deployment of vastly superior instruments, has crossed a terrifying, invisible threshold. It has fundamentally mutated. It is no longer a measurement problem. It is a physics problem. To fully grasp the chilling, existential weight of that distinction is to realize that the ground beneath our feet has completely given way. A measurement problem means that humanity is simply flawed, that we need to build a better ruler or wipe the smudge off our lens. But a physics problem of this magnitude means that the universe itself is operating under a set of fundamental laws that we do not possess. It means that the standard model of cosmology, the beautiful, intricately woven tapestry of mathematics that describes the birth, life, and ultimate fate of everything in existence, is missing a massive, critical chapter. We are sitting in the dark, trying to solve a puzzle where a significant portion of the pieces have been deliberately hidden from us by the indifferent architecture of the void. We are dealing with a cosmos that is physically tearing itself apart faster than our laws of gravity, thermodynamics, and relativity say it should be capable of. It means there are massive, invisible forces moving through the empty space between the galaxies, dragging the fabric of reality into the dark, completely undetected by our science. We have finally built the perfect machine to measure the universe, and the only thing it has successfully measured is the profound, terrifying depth of our own ignorance. The gap is real. It is unbridgeable by our current understanding of reality, and it is silently mocking every equation we have ever written on a chalkboard. We are adrift in a universe that we can mathematically prove we do not belong in, as if the crushing, impossible weight of the primordial galaxies was not enough to severely fracture our understanding of the cosmos. The James Webb Space Telescope has peered even deeper into the fundamental, atomic architecture of the cosmic dawn and uncovered a completely different, far more insidious kind of nightmare. We are not just looking at ancient structures that are physically too massive to exist within the established timeline. We are staring at deep-field objects that are chemically impossible. To truly grasp the terrifying magnitude of this specific anomaly, we must temporarily step away from the grand, sweeping mechanics of gravity and expansion and look at the strict, unforgiving laws of atomic creation. We must look at the actual, physical ingredients that make up the dark void. When our universe was violently born in the fires of the Big Bang, the rapidly expanding, cooling plasma was incredibly, brutally simple in its composition. The intense, unimaginable heat and the blinding speed of the initial expansion only allowed for the creation of the lightest, most basic, and least complex building blocks of physical reality. As the cosmos cooled enough for electrons to finally bind to atomic nuclei, roughly 380,000 years after the beginning, the entire chemical inventory of the universe consisted almost exclusively of hydrogen and helium, accompanied by an incredibly microscopic, practically negligible trace of lithium. For hundreds of millions of years, as the universe plunged into the silent, freezing era known as the Cosmic Dark Ages, this was the absolute totality of the cosmic periodic table. There was absolutely no carbon to eventually build the complex, twisting chains of organic molecules. There was no oxygen to eventually bind with hydrogen and form the vast, deep oceans of habitable worlds. And there was absolutely no iron to forge the heavy, molten cores of terrestrial planets. The early universe was a sterile, pristine, and entirely uniform fog of the simplest possible gases. By the strict, unyielding laws of cosmic chemistry, this pure, unblemished primordial fog is the absolute only raw material that the very first generation of stars had available to them when gravity finally ignited their cores. Those theoretical first lights, known as population 3 stars, should have been massive, blindingly bright, and chemically immaculate, burning nothing but raw, primordial hydrogen in the absolute dark. To get from that sterile, simple fog to the wonderfully complex, heavy chemistry of our modern universe requires a massive, agonizingly slow cosmic assembly line. The heavier elements of the periodic table, what astronomers broadly and simply categorize as metals, do not spontaneously materialize in the freezing vacuum of space. They must be meticulously, violently forged inside the crushing, superheated cores of massive stars. A star is not just a source of light, it is a heavy elemental forge. It spends its entire active life desperately crushing hydrogen atoms together to create helium, releasing the massive amounts of energy required to hold back the crushing, relentless weight of its own gravity. But when a massive star eventually exhausts its primary hydrogen fuel, the core violently collapses inward, the internal temperature spikes to incomprehensible levels, and the star begins to frantically fuse heavier and heavier elements in a desperate, losing battle against its own mass. It forcefully fuses helium into carbon, it crushes carbon into oxygen, and it squeezes oxygen into neon, cascading all the way down the periodic table until it hits the ultimate, fatal dead end, iron. Fusing iron does not release energy, it aggressively absorbs it. The exact moment a dying star's core successfully fuses into solid iron, the delicate, vital balance of the entire machine is instantly and permanently broken. Gravity finally wins the war. The outer layers of the star collapse inward at a significant fraction of the speed of light, hit the unyielding iron core, and violently rebound in a cataclysmic, blinding supernova explosion. It is only in the sheer, unimaginable violence of this final, dying explosion that the heavy elements forged in the core are forcefully expelled outward, seeding the surrounding pristine gas clouds with the heavy, complex ashes of a dead star. This brutal, violent process of stellar alchemy is the absolute only physical mechanism in the universe capable of chemical enrichment. But the most critical, unyielding component of this entire cosmic engine is time. It requires an agonizingly long, sequential, and uninterrupted chain of cosmic generations. The first stars must be born pure, live out their entire lifespans over millions of years. die in massive explosions, and scatter their heavy ashes into the dark. Then, the universe must wait for gravity to slowly, patiently pull those enriched clouds back together to form a second generation of stars. Those stars must then live, die, and explode to further enrich the void. To achieve a massive galaxy that is deeply saturated with complex, heavy elements like carbon, oxygen, and iron, you mathematically require multiple, sequential generations of stellar birth, life, and violent death. In the meticulously crafted standard model of cosmology, this cyclical, generational process is supposed to take billions of years to achieve significant chemical complexity. It is the slow, ticking, irreversible clock of cosmic evolution. This is exactly why the spectroscopic data from the James Webb Space Telescope has induced a state of complete, paralyzing dread among astrophysicists. The telescope is not just taking beautiful, high-definition photographs, it is utilizing its highly advanced near-infrared spectrograph to capture the faint, stretched light from the very edge of time and meticulously split it apart into a highly detailed, high-resolution barcode. This spectral barcode reveals the absolute, undeniable chemical fingerprints of the atoms burning inside those ancient galaxies. When the researchers aimed this instrument at the massive, distant universe breaker galaxies, sitting a mere 500 to 700 million years after the Big Bang, they fully expected to see the pristine, chemically pure signatures of a newborn universe. They expected to read the simple, clean barcodes of primordial hydrogen and helium, confirming that these early structures were indeed the untainted nurseries of the cosmos. Instead, the ghostly light that trickled into the sensors was heavily, undeniably contaminated. The spectral lines dancing across the monitors on Earth were thick, complex, and violently chaotic. The pristine hydrogen was heavily overpowered by the undeniable, screaming signatures of heavy chemistry. The data definitively, empirically proved that those ancient, primordial galaxies are completely saturated with carbon, oxygen, and most terrifyingly of all, heavy, stable iron. The profound existential horror of this discovery lies in the brutal, inescapable simplicity of the timeline. These complex, heavy elements simply have absolutely no physical right to exist in an environment this chronologically young. We are looking at an era of the universe that is theoretically supposed to be the absolute beginning, the pristine, untouched cradle of reality. Yet, the chemical signatures we are detecting are the undeniable, highly concentrated ashes of ancient, long-dead ancestors. For those specific galaxies to be so completely saturated with heavy iron and oxygen at a mere 500 million years old, they would require entire generations of massive stars to have already been born, lived completely full, complex lives, died in cataclysmic supernovae, and had their remains re-assimilated into new stars. The chemical complexity explicitly requires stellar ancestors that lived complete lives before the observed galaxy even had the physical time to form. There simply is not enough mathematical time available between the theoretical moment of the Big Bang and the exact moment those galaxies were photographed for that massive, multi-generational assembly line to have actually occurred. The fundamental chronology of the universe is violently bleeding out right in front of our eyes. Finding heavy iron in the cosmic dawn is exactly like digging into a perfectly undisturbed, ancient geological stratum from the dawn of the Jurassic period and suddenly unearthing a highly advanced, fully assembled titanium jet engine. The object itself is not physically impossible, but its presence in that specific ancient layer of time completely, violently shatters the entire established history of the world. It forces us to confront a terrifying, irreconcilable paradox that threatens to collapse everything we know. Either the stellar engines of the early universe operated at a frantic, terrifying speed that fundamentally violates our understanding of how stars physically burn, age, and die, or the universe itself is vastly, significantly older than the 14 billion years we have so confidently calculated. We built the greatest machine in human history to look deep into the cradle of the cosmos, expecting to find the simple, pure, and comforting ingredients of a newborn reality. But instead, James Webb has found the heavy, complex, and undeniable wreckage of a universe that somehow lived, aged, and died before it was ever even supposed to have been born. We are staring at the spectral lines of iron glowing in the absolute dark, and we are forced to realize that the ancient ghosts haunting the edge of space are older than time itself. The impossible chemistry tells us, with a cold and unforgiving certainty, that the laws of atomic creation we thought governed the void are nothing more than a comforting, local illusion, and the true history of the universe is a dark, sprawling nightmare that our current physics is completely blind to. When a colossal, towering structure finally begins to completely collapse, the ultimate failure rarely manifests as a single, sudden, explosive event. The destruction is almost always preceded by a series of deep, agonizing, microscopic stress fractures. First, we found the sprawling, violently mature galaxies sitting impossibly close to the beginning of time, a massive structural crack in our understanding of gravity and accretion. Then, we uncovered the suffocating, undeniable chemical signatures of ancient, heavy iron burning in a primordial era where only pristine hydrogen should have physically existed, severely fracturing our timeline of stellar evolution. And, simultaneously, we were forced to watch the fundamental expansion rate of the universe ruthlessly split into two irreconcilable speeds, a massive, tearing fissure right down the center of our local geometry. For years, the global community of astrophysicists desperately tried to patch these individual cracks one by one, treating them as isolated, unfortunate anomalies. But the terrible, inescapable truth that is now descending upon the scientific world is that these anomalies are not isolated at all. They are the highly visible, catastrophic symptoms of a much deeper systemic failure. We are no longer just dealing with a few strange galaxies or a slightly miscalibrated distance ladder. We are watching the grand, unifying mathematical framework of modern astrophysics violently collapse under the crushing weight of its own contradictions. To fully comprehend the sheer magnitude of this intellectual disaster, we must listen to the specific, carefully chosen words of the very architects who built the structure. Adam Rees is not merely an observer. He is one of the most consequential, heavily decorated astrophysicists alive today. In the late 1990s, he was one of the brilliant minds who originally discovered that the expansion of the universe was not slowing down, but was actually terrifyingly accelerating into the dark. A monumental discovery that fundamentally altered human history and rightfully earned him the Nobel Prize in Physics. He is a man who understands the deep, hidden mechanics of the void better than almost anyone else on the planet. And yet, when Rees recently confronted the widening, unbridgeable gap of the Hubble tension, the irreconcilable 9% discrepancy between the early universe and the modern universe. He did not offer a comforting, optimistic reassurance. He coldly noted that the discrepancy had officially passed the terrifying 5 sigma threshold, and he publicly stated that something is fundamentally wrong. In the strictly policed, intensely skeptical, and mathematically unforgiving realm of particle physics and cosmology, the term 5 sigma is not a casual descriptor. It is the absolute ultimate gold standard of empirical certainty. It is the exact statistical threshold required to officially declare the discovery of a new particle like the Higgs boson. When an anomaly reaches 5 sigma, it means the mathematical probability of that specific discrepancy being a random, statistical fluke or a temporary stroke of bad luck with the observational instruments is roughly 1 in 3.5 million. It is a statistical death sentence for the status quo. When a Nobel Laureate looks at a 5 sigma discrepancy in the expansion rate of the cosmos and declares that something is fundamentally wrong, it is the academic equivalent of the captain of a sinking vessel, calmly stepping up to the microphone and announcing that the structural integrity of the hull has officially failed. It is the formal, undeniable admission that the mathematical ship we have been sailing through the dark for the last century is taking on water far faster than our equations can possibly pump it out. The ship that is currently sinking, the grand, overarching theory that is violently breaking apart in the freezing dark, is known as lambda CDM. To the layman, it is a cryptic acronym, but to the cosmologist, lambda CDM is the absolute, undisputed operating system of modern reality. It stands for lambda cold dark matter. It is the master software, the beautiful, intricately woven mathematical code that we boot up in our massive supercomputers to render the entire history, structure, and ultimate fate of the universe. This operating system explicitly describes a cosmos composed of a terrifying, highly unbalanced ratio of ingredients. According to the code of lambda CDM, everything we can physically see, touch, and interact with, every single burning star, every sprawling nebula, every crushing black hole, every grain of dust, and every biological entity on Earth accounts for a meager, pathetic 5% of the total universe. We are nothing more than a microscopic, glowing impurity floating in a vast, invisible ocean. Another 27% of the universe is dictated to be dark matter, a completely invisible, ghostly mass that refuses to interact with light but exerts a massive, crushing gravitational pull to hold the spinning galaxies together. And the remaining 68%, the vast, overwhelming majority of reality, is assigned to the cosmological constant, represented by the Greek letter lambda. This is dark energy, the phantom, repulsive force that is actively, aggressively stretching the empty void and driving the accelerated expansion of space. For nearly 3 decades, this incredibly bizarre, heavily patched operating system worked with a terrifying, almost magical perfection. Even though we had absolutely no physical idea what dark matter or dark energy actually were, if we simply plugged those exact percentages, 5, 27, and 68, into our supercomputers, the simulation flawlessly reproduced the universe we saw in our older telescopes. It perfectly predicted the intricate, web-like distribution of galaxies across billions of light years. It flawlessly explained the exact microscopic temperature variations in the cosmic microwave background. We blindly trusted the operating system because it consistently, reliably compiled the code of reality without throwing a single fatal error. We confidently convinced ourselves that we had successfully written the definitive source code of the cosmos. But an operating system, no matter how brilliantly coded, is ultimately only as robust as the hardware it runs on and the specific software programs it is asked to execute. For 30 years, Lambda CDM was running a relatively simple, low-resolution program. It was processing the blurry, distant, highly constrained data provided by the Hubble Space Telescope and ground-based observatories. It was humming along perfectly because we were not asking it to do anything truly demanding. But the launch of the James Webb Space Telescope was not just an upgrade to our optical hardware. It was the equivalent of installing a massive, incredibly aggressive, high-definition stress testing software directly into the core of the ancient operating system. We suddenly asked Lambda CDM to process a staggering, overwhelming flood of incredibly sharp, high-resolution, impossible data from the absolute edge of time. When we fed the operating system the telemetry of the universe breaker galaxies, demanding that it mathematically explain how tens of billions of solar masses could physically assemble in the pitch-black void a mere 500 million years after the Big Bang, the code hesitated. The gravitational equations simply could not compile the mass fast enough. When we fed it the high-resolution spectral barcodes of heavy, ancient iron and complex oxygen burning in an era that was supposed to be completely sterile and filled only with pristine hydrogen, the code violently conflicted with its own internal rules of stellar thermodynamics. And when we aggressively forced it to reconcile the flawless, sharp, modern measurements of the accelerating distance ladder with the pristine measurements of the ancient cosmic microwave background, the software became trapped in an infinite, inescapable, mathematically impossible loop. Like a rigid, outdated computer operating system utterly failing when a new, highly complex program makes an unprecedented, unusual request, Lambda CDM is actively crashing right in front of our eyes. It is blue screening on a cosmic scale. The beautiful, elegant mathematical framework that perfectly described the universe of 1998 is violently, fatally incapable of describing the high-definition universe of 2026. The equations are breaking down, the variables are spinning wildly out of control, and the fundamental laws we wrote to govern the dark simply refuse to execute. This catastrophic system failure induces a deeply profound, almost suffocating wave of existential dread. We are suddenly forced to confront the chilling reality that the 5% of the universe we thought we perfectly understood is behaving completely irrationally, and the 95% of the universe that is invisible to us might be operating on a completely different, entirely alien set of physical laws that we haven't even begun to comprehend. We relied on Lambda CDM to be our absolute, infallible guide through the terrifying, sprawling dark of the cosmos. We used it to assure ourselves that the universe, while vast and incredibly hostile, was ultimately rational, predictable, and mathematically sound. But as the James Webb Space Telescope continues to ruthlessly hammer the system with impossible data, tearing down the firewalls of our assumptions one by one, we are left staring at a blank, frozen screen. The operating system of cosmology has crashed, and as we sit in the dark, desperately trying to reboot the mathematics of reality, we are haunted by the terrifying, paralyzing realization that we might have to completely rewrite the laws of physics from absolute scratch in a universe that we now know is infinitely stranger, infinitely older, and infinitely more dangerous than the one we originally programmed. when the towering, impossible structures of the ancient galaxies first began to fracture our understanding of gravity, and when the heavy, suffocating signatures of primordial iron crushed our timeline of stellar evolution, the global scientific community desperately clung to one final, supposedly unshakable mathematical anchor. If the visible baryonic matter of the cosmos was behaving irrationally, if the stars and the gas were actively mocking our equations, we still believed we could find a cold, sterile comfort in the absolute silence of the void itself. We sought refuge in the massive, invisible phantom that dominates 68% of our entire reality, dark energy. Within the intricately woven architecture of the standard cosmological model, dark energy is mathematically represented by the Greek letter lambda, the symbol for the cosmological constant. The word constant is not merely a mathematical placeholder. It is the ultimate, non-negotiable key to our entire perception of infinity. Originally introduced by Albert Einstein as a theoretical necessity, and later violently resurrected to explain the terrifying, accelerating expansion of space, the cosmological constant was explicitly defined as an eternal, immutable property of the vacuum. It coldly dictated that a specific, identical amount of repulsive energy would always exist in every single cubic meter of empty space, from the chaotic dawn of time until the freezing, eternal death of all things. It was the absolute, unwavering compass of the universe, the steady, predictable engine driving the stretching of reality. We built our entire understanding of the future upon the strict assumption that, while galaxies might collide, stars might die, and matter might decay into dust, the dark energy tearing it all apart would never, ever change its core strength. To definitively prove the immutable nature of this cosmic engine, and to precisely map its history of acceleration, humanity constructed an instrument of unprecedented, terrifying ambition. High atop an isolated, freezing mountain peak in Arizona, deep inside the Mayol telescope, we installed the Dark Energy Spectroscopic Instrument, a massive robotic eye known simply as DESI. This machine was not built to capture beautiful, sweeping photographs of colorful nearby nebulas. It was designed as a cold, industrial, high-speed cartographer of the deep abyss. Equipped with exactly 5,000 robotic optical fibers, each moving with a relentless mechanical precision, DESI was programmed to stare blindly into the dark and plot the exact three-dimensional coordinates of over 6 million individual galaxies. It reached its vision across 11 billion years of cosmic history, carefully tracing the web-like distribution of matter spreading across the expanding ocean of space. The ultimate goal of this monumental survey was to track the faint, fossilized echoes of primordial sound waves known as baryon acoustic oscillations, which had been permanently frozen into the distribution of galaxies shortly after the Big Bang. By using these ancient, frozen ripples as a perfect, unyielding cosmic ruler, scientists believed they could measure exactly how the expansion rate of space had behaved across eons. The mathematical expectation was beautifully simple and deeply comforting. If lambda was truly a constant, if the dark energy driving the expansion was an eternal property of the vacuum, then the massive, three-dimensional map generated by DESI would reveal a perfectly smooth, flat, and entirely predictable line of acceleration. The engine of the void would hum at the exact same steady frequency throughout the entire 11 billion year timeline. In the early months of the year 2024, after processing a volume of incredibly complex data so massive it threatened to crash supercomputers. The international team of physicists prepared to announce their findings. They fully expected to publish a rigorous, highly detailed confirmation of the standard model, driving the final, definitive nail of certainty into the concept of the cosmological constant. But when the final data materialized on the monitors, the straight, comforting line of reality brutally and violently snapped. The compass of the cosmos was drifting aimlessly in the dark. The meticulous mapping of those 6 million galaxies revealed a terrifying, inexplicable curve in the expansion history of the universe. The actual, effective value of the dark energy pushing the galaxies apart was not standing still, it was shifting. The data strongly and undeniably indicated that the repulsive force of the vacuum was actually evolving across cosmic time. In certain ancient eras of the universe, dark energy appeared to be inexplicably weaker, and in other epochs, it surged with a terrifying, overwhelming power. The mathematical anchor of our entire existence, the single, unyielding constant that defined the operating system of lambda CDM, had completely and fundamentally failed to hold its value. When astrophysicists are forced to confront the chilling reality that dark energy is not a fixed number, they have to adopt a new, deeply destabilizing theoretical framework known as dynamical dark energy. To truly understand the supreme, existential horror of dynamical dark energy, you must realize what it actually means for the vacuum of space to alter its fundamental physical properties. If the cosmological constant is truly constant, the universe is a predictable machine. We know exactly how it ends, slowly expanding forever until the stars burn out and the cosmos descends into a freezing, silent heat death. It is a profoundly depressing fate, but it is mathematically stable. However, if dark energy is dynamical, if it is an active, shifting, and evolving field of energy that changes its own core strength as the eons pass, then the universe is not a predictable machine at all. It is a chaotic, volatile, and terrifyingly unpredictable entity. The concept of a shifting dark energy terrifies theoretical physicists because it violently attacks the very definition of empty space. In quantum mechanics, the vacuum is never truly empty. It is a boiling, chaotic sea of virtual particles constantly popping in and out of existence, contributing to the baseline energy of the void. For dark energy to evolve, for its repulsive strength to shift across billions of years, implies that this fundamental quantum baseline is inherently unstable. It means that the absolute lowest energy state of the universe, the very floor of reality itself, is slowly moving beneath our feet. If the vacuum itself can alter its properties, then the fundamental constants of nature that govern our microscopic world, the mass of an electron, the strength of electromagnetism, the binding force of atomic nuclei, might also be subtly, invisibly tied to this shifting cosmic tide. The drifting compass of dark energy threatens to bleed down from the massive scale of galaxy clusters directly into the fragile, microscopic architecture of our own bodies. It destroys the illusion of a permanent, stable reality, replacing it with a horrifying vision of a universe that is constantly, silently mutating. This specific discovery strips away the final, comforting layer of terrestrial arrogance. We are no longer observing a static, obedient void. We are trapped inside a universe where the fundamental force tearing at the fabric of reality possesses a variable throttle, and we have absolutely no physical understanding of what invisible hand is actually pressing the pedal. A dynamical, shifting dark energy means that the empty space in your room, the void between the planets, and the massive, yawning abysses between galaxy clusters are actively, invisibly changing their fundamental nature as the clock ticks forward. It suggests that the laws of physics governing the macro-universe are not carved into immutable stone, but are written on a fluid, shifting medium that we completely lack the capacity to read. The psychological shock of the DESI data on the scientific community is profound and suffocating. We built Lambda CDM on the strict assumption that the lambda part was the only thing we could truly count on. But that map of 6 million galaxies forced us to watch the bedrock of modern physics completely liquefy. We are adrift in an ocean that is not just expanding, but is actively changing the physical rules of its own expansion. If the density of dark energy can shift over billions of years, it opens the door to a gallery of terrifying, apocalyptic cosmic fates that we previously dismissed as fringe mathematical theories. It means we cannot confidently predict the future of the universe because the very engine driving that future is unstable. It might surge exponentially, leading to a catastrophic big rip where the fabric of space-time itself is violently torn apart down to the subatomic level, destroying every atom in existence. Or it might mysteriously weaken and reverse, pulling the expanding cosmos back into a crushing apocalyptic big crunch. We are forced to look at the magnificent, sprawling web of galaxies mapped by DESI and realize that we are completely, utterly blind to the true mechanics of the dark. The invisible phantom that makes up nearly 70% of our universe is not a static, steady presence. It is an evolving, restless leviathan moving through the abyss. We spent decades trying to map the structure of the cosmos, believing that if we could just measure the walls of our cage with enough precision, we could understand the nature of our confinement. But the drifting compass of dark energy reveals a far more terrifying truth. The walls of the cage are moving. The geometry of the void is actively shifting in the dark. And as we sit before our monitors, staring at the fluctuating numbers of an evolving cosmological constant, we are paralyzed by the realization that the universe is completely untethered, actively rewriting its own fundamental laws as it accelerates into the freezing black night, leaving humanity blindly guessing what terrifying reality it will decide to become next. The revelation that the fundamental engine driving the expansion of the cosmos is not a fixed, immutable constant, but a shifting, dynamic, and potentially volatile force, violently shatters the final, comforting illusion we held about our ultimate destination. For decades, the standard picture of cosmology offered us a very specific, mathematically rigorous, and quietly melancholic prophecy for the end of all things. Because we blindly assumed that the cosmological constant, lambda, was an eternal, unchanging property of the vacuum, we confidently projected a future defined by a slow, agonizingly peaceful fading of the light. We predicted a scenario known as the heat death or the big freeze. In this rigidly defined future, the steady, unchanging pressure of dark energy would simply continue to push the galaxies further and further apart, isolating them in an ever-expanding, freezing void. Over trillions of years, the great stellar nurseries would exhaust their supplies of primordial gas. The brilliant, burning stars would slowly wink out, one by one, leaving behind only the cold, dead embers of white dwarfs, neutron stars, and the silent, crushing mass of black holes. Eventually, Even these remnants would decay or evaporate through Hawking radiation, leaving a universe that is completely dark, eternally expanding, and uniformly resting at absolute zero. It was a deeply depressing, desolate fate, but it was a quiet one. It offered a sense of mathematical closure, a peaceful surrender to the unrelenting laws of thermodynamics. But the terrifying data confirming the existence of dynamical dark energy completely rewrites the final chapter of the universe, tearing up that peaceful prophecy and replacing it with a gallery of violent, apocalyptic nightmares. If the repulsive force of the vacuum is actively evolving, we are no longer passengers on a steadily coasting ship slowly running out of fuel. We are strapped to a volatile, unpredictable cosmic explosive, and we have absolutely no idea what the timer is set to. If the shifting effective value of dark energy means that this phantom force is actually growing stronger over time, accumulating power as space expands, it will eventually completely overwhelm every other fundamental force in physics. This scenario triggers an apocalyptic event known as the Big Rip, and it is arguably the most violent, terrifying end conceivable. In the standard model, dark energy is only strong enough to stretch the empty space between incredibly distant galaxy clusters. The localized gravity within a galaxy is easily strong enough to hold the spinning stars together against the outward push of the void. But if dark energy is dynamical and exponentially increasing in strength, that invisible, repulsive pressure will eventually cross a critical threshold. It will no longer just push distant galaxies away from us. It will begin to aggressively invade our local geometry. The horror of the Big Rip unfolds in a strict, inescapable, and violently accelerating sequence. First, the incredibly powerful gravitational bonds holding the massive galaxy clusters together will simply snap. The great cosmic web will dissolve, and the Milky Way will be entirely permanently isolated in the dark. But the surging dark energy will not stop there. As its repulsive strength continues to exponentially rise, it will physically overpower the gravitational glue holding our home galaxy together. The spiraling arms of the Milky Way will be violently shredded, its hundreds of billions of stars violently flung outward into the rapidly expanding, freezing night. The night sky of any planet still surviving will go completely, instantly black as the neighboring stars are pushed away at speeds exceeding the speed of light. Yet, the true, microscopic horror of the Big Rip is still to come. The surging phantom energy will eventually grow so unimaginably powerful that it overpowers the localized gravity of individual stellar systems. The planets will be brutally ripped from their orbits around the dying sun, flung into the freezing void like discarded debris. Shortly after that, the repulsive force of space itself will become stronger than the gravitational binding energy of the planets. The crust of the Earth will shatter, the mantle will violently boil outward, and the planet will literally explode into dust as the very space occupying its volume forcefully expands. Finally, in the last, agonizing fraction of a second before the end of time, the dark energy will overpower the electromagnetic and strong nuclear forces. The fundamental bonds holding atoms together will fail. The electrons will be ripped from their nuclei. The protons and neutrons will be torn apart into raw quarks. And then the fabric of space-time itself will violently shred. The universe will not end in a slow, quiet freeze. It will be aggressively, maliciously torn apart down to its most fundamental, subatomic particles, leaving absolutely nothing but a rapidly stretching, infinitely expanding, screaming void. Conversely, the shifting, dynamic nature of dark energy presents a completely different, equally horrifying apocalyptic alternative. If the dark energy is not growing stronger, but is actually slowly decaying, weakening, or perhaps even preparing to completely reverse its polarity, the universe is accelerating toward a fundamentally different execution. What if the repulsive force of the vacuum is a temporary, transient phase of the cosmos, an ancient, cosmic wind that is slowly dying out? If the dark energy powering the expansion gradually fades to zero, the universe will stop accelerating. It will coast for billions of years, slowly grinding to a monumental cosmic halt. And then, the immense collective gravitational pull of all the dark matter, stars, and black holes in the universe will finally, definitively reassert its dominance. The expansion will stop, hesitate, and then violently shift into reverse. The universe will begin to fall back in on itself, initiating an apocalyptic collapse known as the Big Crunch. The horror of the Big Crunch is the horror of inescapable, claustrophobic compression. As the universe begins to contract, the galaxies that have been running away from us for 14 billion years will stop and turn around. Slowly at first, and then, with terrifying, accelerating speed, they will begin to rush back toward us. The night sky, which has been expanding and cooling into the microwave spectrum for eons, will begin to visibly change. As the entire volume of the cosmos shrinks, the ancient, invisible cosmic microwave background radiation will be compressed, its wavelengths brutally squeezed together, causing it to aggressively blue shift. It will shift from harmless microwaves back into infrared, then into visible red light, then into blinding, searing white light. Long before the galaxies actually physically collide with each other, the shrinking void of space will become a suffocating, inescapable cosmic oven. The ambient temperature of the empty vacuum will rise so drastically that it will eventually become hotter than the glowing surfaces of the stars themselves. The stars will no longer be able to radiate their internal heat into space. Instead, they will be violently cooked from the outside in. The planets will be stripped of their atmospheres and incinerated into oceans of boiling magma merely by the ambient heat of the shrinking void. As the compression accelerates into its final stages, the supermassive black holes lurking at the centers of the colliding galaxies will merge together, creating monolithic, devouring monsters that swallow the boiling remains of the stars. In the final, unimaginable moments, the entire sum of all matter, energy, and space-time in the cosmos will be crushed back down into a single, infinitely dense, infinitely hot singularity. The vast, sprawling majesty of the universe will be violently compacted into a microscopic point of absolute, crushing destruction, entirely erasing 14 billion years of cosmic history, structural evolution, and the quiet, desperate struggles of any biology that happened to exist within it. We are left paralyzed by the realization that we are standing completely blindfolded at the edge of infinity. The standard model of cosmology provided us with the comforting illusion of certainty. We thought we had mathematically decoded the final act of the play, but the shifting, drifting data from our latest instruments has violently snatched that script from our hands, leaving us entirely adrift. We do not know if the invisible phantom that rules our universe intends to slowly freeze us in the dark, violently rip our atoms apart in a catastrophic shredding of reality, or relentlessly crush us into a boiling singularity. The silence of the night sky is no longer a peaceful, majestic canopy. It is the heavy, agonizing silence of a loaded weapon, and we are sitting in the dark, completely incapable of predicting which terrifying mechanism the universe will ultimately use to pull the trigger. We are forced to live with the profound, existential dread that the laws of physics are not a shield protecting us from the chaos of the void, but are actively writing the very blueprints of our own unavoidable execution. When the final, indisputable telemetry from the dark energy spectroscopic instrument finally settled onto the servers, it did not arrive with a triumphant fanfare or a sudden, brilliant flash of scientific clarity. It arrived with the heavy, suffocating silence of a definitive, undeniable verdict. We have spent this entire session meticulously peeling back the layers of our cosmic ignorance, descending step by agonizing step into a reality that aggressively refuses to obey the laws we wrote for it. We watched the massive, impossible universe breaker galaxies violently defy the slow, methodical physics of gravitational accretion. We stared at the high-resolution spectral barcodes of ancient, heavy iron burning in a primordial era that was mathematically mandated to be chemically sterile. We stood paralyzed before the widening, unbridgeable chasm of the Hubble tension, watching the fundamental expansion rate of reality tear itself into two irreconcilable speeds. And finally, we looked out into the absolute, freezing void itself, desperately hoping to find a stable, unwavering, mathematical anchor in the cosmological constant, only to discover that the very compass of the universe is drifting aimlessly in the dark. The DESI data has spoken, and the terrifying answer it has handed down to us is profound, absolute instability. For decades, the global cosmological community operated under a powerful, deeply comforting illusion. We genuinely believed that we were in the final, meticulous stages of writing the ultimate, definitive textbook on the architecture of reality. We thought we had successfully decoded the fundamental software of the cosmos. We were so incredibly confident in our elegant equations that we arrogantly began to write the final chapter of the universe, based entirely on the strict, unyielding assumption that the dark energy pushing the galaxies apart was an eternal, unchanging constant. We projected our mathematics trillions of years into the deep future. We confidently predicted the slow, agonizing heat death of all things, the quiet, freezing fade of the last stars, and the eternal, static silence of an infinitely expanded void. We wrote a highly detailed, mathematically rigorous eulogy for the entire cosmos. But the terrifying shifting data from the DESI survey has violently ripped those final pages from our hands and burned them in the dark. We were writing the ultimate fate of reality based on a fundamental constant that turned out to be completely, catastrophically misread. The verdict is officially in, and it carries a crushing, existential weight that the scientific world is still struggling to physically process. The grand, unifying framework describing everything we know about the universe, the beautifully complex operating system of lambda-cold dark matter, has unequivocally failed. It is broken. The software has crashed, and no amount of subtle tweaking, theoretical patching, or desperate recalibration can force it to run the impossible. High-definition reality that the James Webb Space Telescope and DESI have placed before us. We must accept the chilling reality that the 5% of the universe we can actually see is behaving irrationally, and the 95% of the universe that is entirely invisible to us is an evolving, shifting, and highly volatile leviathan. But the absolute true horror of this specific moment in human history is not merely that our old framework has been destroyed. The paralyzing dread comes from the terrifying realization that the replacement framework has not yet been found. We are completely, entirely adrift. When Albert Einstein violently shattered Isaac Newton's clockwork universe with his theories of relativity, he immediately provided a new, vastly superior mathematical architecture to replace it. He tore down the old house, but he handed us the blueprints for a much grander mansion. But today, right now, we have absolutely no blueprints. We have successfully burned the old house of cosmology to the ground, and we are left standing in the freezing, open night, completely exposed to the chaotic, incomprehensible elements of the void. We have no unifying theory to explain how tens of billions of solar masses can assemble in the blink of a cosmic eye. We have no equations to explain how dark energy can dynamically shift its strength across eons. We are staring at a universe that is wild, untamed, and fundamentally alien to our current logic, and we do not possess the mathematical vocabulary to even begin describing it. To truly visualize the existential trap we are currently caught in, imagine a biologist meticulously studying the behavior of fish in a small, beautifully illuminated research tank. The biologist maps their movements, writes rigorous equations describing their schooling patterns, and confidently believes they have completely mastered the physics of that specific aquatic world. All of their observations are mathematically accurate. But then, someone points out that the small research tank is actually sitting inside a vastly larger, darker, and completely unseen ocean with entirely different temperatures, chemical currents, and gravitational pressures that subtly, invisibly influence everything the fish do. Everything the biologist observed was technically accurate within the confines of the small tank, but it was absolutely, fundamentally not the whole story. Humanity is that biologist. Our entire observable universe, the 14 billion light-year sphere that we can actually see, is nothing more than the inner tank. We wrote the laws of physics based entirely on what we could observe from the inside. But the James Webb Space Telescope and the DESI instrument are the very first tools we have ever built that are sensitive enough and far-reaching enough to finally notice that the fish are behaving in terrifying ways that the chemistry of the inner tank simply cannot explain. We are observing the undeniable, ghostly influence of the larger, darker ocean pressing in on the glass. We are forced to confront the chilling possibility that we live in a universe that appears to run on universal, unbreakable laws. But those laws turn out to be entirely local, temporary, and flawed. We are living in a space-time that feels absolutely fundamental to our human senses, but actually emerges from deeper, hidden, and terrifying quantum relationships that do not themselves live in space as we understand it. And inside all of that, on one tiny, fragile planet, in one ordinary galaxy, in one microscopic bubble of reality, there is a species that notices. There is something that builds a $10 billion telescope, points it at the absolute beginning of time, and finds that the beginning does not match the model. I do not know what it ultimately means that the universe somehow produced a biological entity capable of noticing that it fundamentally does not understand the universe. What I do know is that the terrifying question James Webb has opened is no longer just a debate about the mass of distant galaxies or the spectral lines of ancient iron. It is a profound, existential question about what kind of thing the universe actually is. We are forced to look at the sprawling, infinite dark and admit that the answer we have been searching for is not the comforting yes we expected. This is the unanswered question in the dark, and it is a heavy, suffocating burden for the human mind to bear. We built the most magnificent machines in history to seek reassurance, but the universe did not offer us any. It simply looked back at us and revealed a reality so staggeringly complex and inherently volatile that it instantly rendered a century of our best physics obsolete. We must now learn to live with the profound, deeply humbling discomfort of absolute uncertainty. The cosmos is not a solved equation. It is a dark, shifting, and deeply unpredictable abyss. As we bring tonight's session to a close, I want you to sit in the quiet of your room and let the immense, crushing weight of that unknown reality wash over you. Think about the James Webb Space Telescope, silently hanging out there in the freezing dark, millions of miles away from the warm, chaotic surface of Earth. It is still awake. Its golden mirrors are still perfectly aligned, its sensors are still incredibly cold, and it is still relentlessly, patiently drinking in the ancient, impossible photons from the very edge of reality. The telescope is still looking. The data is still arriving on our servers every single day, slowly decoding the secrets of the abyss. But the profound, deafening silence where our comforting, mathematical answers used to be is only getting louder, heavier, and more absolute. We are alone in the dark, holding a machine that has blinded us with the truth. Rest easy tonight, knowing that the universe is far wilder, far stranger, and infinitely more magnificent than we could ever possibly calculate. Let the mystery of the dark void quiet your mind, and let the unanswered questions of the cosmos carry you into the absolute stillness of the night. Good night, everyone, and I will see you in the next video.